Hello AP Calculus students. It's been a while since I recorded a video for grading, working out these multiple choice questions. So let's just get right into it. We have Unit 7 and there's only 10 questions for this one. In Unit 8 we'll have 20 and then the calculator problems are going to have about 25. So again, just a reminder, all of these questions should be done without a calculator. So let's just jump straight into it. All right, number 121. The equation y equals e to the x minus 2 is a particular solution to which of the following differential equations? So it looks like here they have the y prime and the y, and so yeah, essentially. So I mean, we're already given y right there. So I'm going to figure out what y prime is. So y prime is just equal to the derivative of that is just going to be e to the x. And then, okay, so it looks like they're either adding or subtracting. So they're all kind of in the same form. So it looks like they have like the y prime first and then the y. So let me just start with the subtraction. So if I subtracted them, I know that y prime was e to the x and y itself was minus parentheses e to the x minus 2. So if I subtracted those expressions out, that'll be equal to e to the x minus e to the x plus 2 if I distribute the negative. And then these cancel out, and I'm just left with 2. So I think that answer is just B, right? But then if I just added them instead, I'll have e to the x plus e to the x minus 2, which would give me 2e to the x minus 2. So it's neither of those answers anyways. All right, cool. So for number 1, I just wanted to verify that. So for number 122, which of the following is a solution to the differential equation y double prime plus y is equal to 0? So I guess they want me to take the second derivative of all of these and then add it to the original. So, okay, well for this one, if I did y prime, that's equal to 1 over x. Y double prime would be x to the negative 1 power rule would be negative 1 over x squared. So if I added this in the original, that does not equal 0. So no, it's not A. If I did the first derivative, it would be e to the x. The second derivative would be e to the x. And if I added, I'm adding those two. If I added those two, it would not equal 0. This would just be y prime is equal to 1, y double prime is equal to 0. So if I added the y and the y double prime does not. This one, on the other hand, yeah, I should have just looked at that and said that that was the answer choice. But whatever. If I did the first derivative, that would be cosine of x. If I did the second derivative, the derivative of cosine is negative sine of x. So that works out. If I added the y double prime and y prime, like what they're asking for here, that would equal 0 because the signs would cancel out. Cool. I already saw when I printed these out that slope fields, easily my biggest weakness. So I think what I decided when we were doing chapter 7, I think for me the best way of approaching these is just kind of looking at the positive slopes. Positive slopes or positive negative slopes, whatever. I'm going to look and see if I look, let me just kind of focus on the first quadrant here. In the first quadrant, all of my x values are positive, all of my y values are also positive. So if I look at this, that means that my x values are positive and my y values are positive. Right? So if I multiply a positive by a positive, then I should get positive slopes. Right? Positive slopes. Right? Because hopefully you guys understand that this represents the slopes because this is our slope field. So for my first quadrant x and y, I should get positive slopes. So that kind of already helps me eliminate A and D, because if you look at these, all of the slopes in the first quadrant are kind of like in a downward motion. So those are all negative. Here, all of my slopes are also kind of in a downward motion. So those are all negative. So that kind of at least helps me eliminate that. So all right, so I know it's between B and C. Well, I know these are all negative slopes, negative slopes, negative slopes, negative slopes. Yeah, so okay, I guess that doesn't really help anymore. Hold on, let me erase this and see if that. Just kind of seeing a clear picture. Okay, so I think I already did away with the whole positive negative slopes. Oh, I know here. It looks like there's like a whole bunch of horizontal slopes, right? That's like one thing. This one doesn't necessarily have horizontal slopes there, right? Only the other one. So does that make sense for it to have horizontal slopes? Yeah, it does. Because for all of these values, These points are pretty much like 0, 0, obviously, 1, 0, 2, 0. So pretty much whenever y equals 0, right, add like all of my y equals 0 values, then my slopes are 0. And that makes sense. So this one definitely works. Whereas for this one, that doesn't necessarily have that. So yeah, so at any time my y equals 0, then I have horizontal slopes. Let me do a different color. Then I have horizontal slopes. Anytime my x is 0, which is pretty much all of these values along the y-axis, all of my slopes are 0 as well. So I'm going to go with B. Okay. I hope so. So far, I don't think I've been wrong too many times. I know I made that one mistake for that one Unit 6 multiple choice where I had to, like, I think I used 4/5 instead of 4/3, but anyways, let's go to number 124. Another slope field. Great. The slope field shown above corresponds to which of the following differential equations? Okay, let me use my principle of positive slopes. So first of all, if I look at the first quadrant, I have positive slopes, right? So that means that my x, if my x is shoot. Undo. If my x is positive and my y is positive, like, because these are all coordinates in the positive x-axis, positive y-axis, then my slope are all in a positive direction, right? So my slopes should be positive. So let me kind of see if that no, that doesn't really help me eliminate anything. Actually, no, it would be better if I looked at I'm telling you, I hate slope fields. Actually, let me look at this quadrant right here. This is telling me that if my x is positive and my y is negative, because I'm in the positive x-axis and negative y-axis, then my slopes should be negative. Okay, so let's see if that works. If I plug in a positive, so if I plug in a positive for x and a negative for y, then that ends up being negative slopes. My dy dx is negative. See, I can eliminate now. I know I can eliminate B now, right? Wait, no, I can't eliminate B because then, no, yes, I could, because here if I have a positive value, nope. If that's positive, that's negative, then that makes the whole thing negative. So crap. So A works, B works. This is one I can eliminate because here if I have if I have a positive x. But then down here, if I plugged in a negative for the y, I'll end up with a positive, so that's positive slopes in the third quadrant. So I can eliminate C, and kind of the same thing here. If I plugged in a negative in for y, then that'll be a positive on the bottom. If I plugged in a positive in for x, that'll be a positive top, so I'll end up with positive slopes when I should have negative slopes. So I can eliminate D. I don't even know if this is like a good explanation. Okay, so that's that. So let me erase that now. Now let me look at this third quadrant, right? This is kind of one where I also have negative slopes, right? So now my eraser. Now that I eliminated C and D, let me look at my third quadrant. So in my third quadrant, I'm in the negative x-axis and negative y-axis. So my x's are negative, my y's are also negative, and I end up with a negative slope. Right? So let's see if that happens when I do. So if I plugged in a negative in for x, I'll end up with a positive on the top because that's going to square the negative. If I plug in a negative for the y, I'm going to end up with a negative on the bottom, which gives me a negative slope overall. So far A still works. However, if I plugged in a negative in for the x and a negative in for the y in this differential equation, then I'll end up with a positive slope, but I can't because all I have are negative slopes there. So the answer is A. Oh my God, I hope I'm right. I really do, because that's going to be really embarrassing, and if I don't get that right, then I'm just going to say that I don't know how to teach slope fields, and I'll just send you guys a YouTube video. All right. So for 125, in which quadrants is the... Oh my God. They're still going to keep going with these slope fields. All right, so is the differential equation dy over dx equal to xy squared over e to the y always negative? When is it always negative? Well, the thing is, I know that no matter what, my y squared, that's always going to be a positive value. And my e to the y, that's always going to be a positive value, right? Because if you think about like an exponential function, that never falls below the x-axis, right? So my exponential function is always positive. And even if you think about like negative y, like if I have e to the negative 5, that'll just be 1 over e to the 5, which is still positive. So these two values are positive no matter what. So really, the only thing that'll make this whole thing negative is if my x value is negative. And if I think about like the coordinate axis, then my x values are only negative in quadrants 2 and 3. So I'm going to go with B. Okay. For number 126, if dy over dx is equal to 4xy, and if y equals 1 when x equals 2, then y... Okay, finally. Now we're getting to to some stuff that I actually like. So this we're going to have to do separation of variables because they want you to figure out the particular solution y when y equals 1 and x equals 2. So let's go ahead and do that. So if I look at this expression, I'm going to make sure that I attach my dx with my x terms and attach my y with my dy terms. So I can multiply dx there, so I'll have 4x dx, and then if I divide both sides by y, then I'll end up with dy over y. And if this were a free response question, that right there, that alone would just give you 1 point. So now I can integrate both sides, and I have the natural log of the absolute value of y is equal to, and then 4x squared over 2 is just 2x squared, and then don't forget the plus c. So at this point is when I think it would be beneficial to go ahead and plug in the 1 and the 2 directly into this. So y equals 1, that's the natural log of 1, is equal to, and then I plug in 2 into that, that'll be 2 times 4, because 2 squared is 4, plus c. So that becomes 0, and then if I subtract 8 from the other side, c is equal to negative 8. So now I'm going to go back into this, and I'm going to just plug that into like this equation. So then I'll have the natural log of the absolute value of y is equal to 2x squared minus 8. And so now from here, what I can do is I can just exponentiate both sides. So then that'll kind of like, get rid of that, and I'm left with the absolute value of y is equal to e to the 2x squared minus 8. And then the thing is, I can write this as y is equal to plus or minus e to the 2x squared minus 8. And I guess we're going to have to double check. Like if I plug in, although I'm looking at the answer choices, I don't even think I have to double check. Because really the only one that even looks like that is A, whether it's plus or minus. There's no 2 or 4 or 8. But just to double check and just for good practice, if you want to know whether you're dealing with a plus or a minus, you're going to have to plug in your initial condition and see which one actually works, the plus or the minus. Because if you think about it, if I plug in 1 in for y, that'll be 1 equals. And then if I do plus or minus e to the, if I plug in 2 in for x, that'll be 8 minus 8, which will be e to the 0 power. So then you know that this is going to be 1, right? So then let's see, is it going to be the plus or the minus? Because if I go with the minus, the negative 1 does not equal 1. The negative 1 on this side does not equal positive 1 on that side. So we know that the answer is going to use the positive. So that's why it's y is equal to positive e to the 2x squared minus 8. I think hopefully there's a multiple choice question that actually forces you to use the negative or to test it out, because I've seen that quite a bit. All right. 127. Consider the general solution y equals f of x to the differential equation dy dx equals y over x. To what function family does f of x belong to? So they gave you the slope and they want to know like what is f of x or y? What family does that belong to? Well, I'm just going to do separation of variables because I'm going to figure out what the y is. So I'm going to multiply the dx over to that side and divide the y to that side. So that'll be dy over, I already know what this is going to be. All right, so dy over y is equal to dx over x. I'm going to integrate both sides, so that's the natural log of y is equal to the natural log of x plus c. And then if I exponentiated both sides, then that's going to go away, and I'm going to have, and that's going to go away. Wait, no, hold on. Let me, before I do that, that's going to be y is equal to, and let me break this apart. That you can rewrite this as e to the natural log of the absolute value of x times e to the c power. And e to the c is just going to be a constant. So that's like the same thing as saying y is equal to e to the natural log, oh no, y is equal to c e to the natural log of the absolute value of x, right? And then that cancels out. So it's almost like saying y is equal to cx in a way, right? And that to me looks like a linear function, right? That's like saying y equals 2x. It's a linear function. Okay, so now for number 128, if dp over dt is equal to p minus 3 and p of 4 is equal to 2, then the expression for t... Okay, so again, another separation of variables problem. So I'm going to get this whole thing and divide it to this side. So I'll have dp over p minus 3, and then I'll multiply the dt to that side, so it'll just be kind of 1 dt. So if I integrated this, I'm going to have the natural log of p minus 3, which I know if you want to do u substitution to prove it, you can. You should just know that if it's a linear function, then you'll just do 1 divided by the u prime, but in this case it'll just be 1. But anyways, so that's equal to t plus c. Okay, so then now at this point, if they gave me an initial condition, I'm going to plug this in. So this is like, so the t is inside the parentheses. So I know that for t equals, for t equals 4, p is equal to 2. Why did that like, sorry, OCD. Okay, so then I'm going to plug in 4 in for t, so that's equals to 4 plus c. And then if I plug in 2 in for that, that'll be the natural log of the, good thing we have our absolute value, right? Because you can't take the natural log of a negative number, but because we're forcing it to be positive with the absolute value, the natural log of just positive 1 now is just going to be 0. So if that side is 0, I can subtract 4 from both sides, and then c is equal to negative 4. All right, so now let's go back to like this function. So that's the natural log of the absolute value of p minus 3 is equal to negative 4 plus c. No, the heck? C is negative 4. So t minus 4. Whoops. Okay, so now I'm going to exponentiate both sides. So now that's going to go away. And now I have the absolute value of p minus 3. I think this is 1. So if e to the t minus 4 power. Right? So then in other words, p minus 3, when I get rid of the absolute value, it's equal to plus or minus e to the t minus 4. Right? And then if I plugged in, now again, is it going to be the plus or is it going to be the minus? So I'm going to go ahead and plug in my my initial condition, the t equals 4 and p equals 2. And let's see what happens. If I plugged in p equals 2, I'll have 2 minus 3. I'll just put negative 1. Save myself some space for the next question. So that'll be negative 1 is equal to plus or minus e to the, and then 4 minus 4 would be 0 power. So that's essentially negative 1 is equal to plus or minus 1, right? So in this case, this is that case where the left side has to be negative. So that means we have to go with the minus when it comes to the plus or minus. So ultimately, it's p minus 3 is equal to negative e to the t minus 4. And then I'm going to add 3 to both sides. And that is c, right? So, yeah. Yes, good. And even though, I mean, you probably could have just chosen c because that's the only one that had make you do the plus 3 on the other side. But whatever. This is essentially how you do it, all right? And that's how you test to see if you're going to use the plus or minus version of your differential equation. Okay, so now for 129, it says if dy over dx is equal to ky, where k is a constant and y is 0. Oh, this is the one where if you see it in this form, dy over dx is equal to ky, if you have just the constant times a y by itself, hopefully you remember that shortcut that it's y equals c initial, like our initial condition, of e to the kx power. Okay? So, anyways, they say that our initial condition at 0 is 100. So y equals 100. E to the, and then our x is 3 in this case. So we'll do 3k. And that is c. Nice. That was easy. It's nice knowing the shortcut. Otherwise, you're going to have to sit there and do the whole differential equation. Okay. So for 130, the rate at which a chemical element decays is directly proportional to the amount of the element remaining. Suppose 20 grams of the element is present at t equals 0. So that's our initial condition. I'm assuming we're going to use this like a formula. At t equals 2, 5 grams of the element is present. Which of the following equations can be used to find the correct constant? So I know that if I use that y equals c initial e to the k x power, I guess in this time, since we're dealing with time, it should be kt power. They say that that there's 20 at time t equals 0, so that's our c value. So y is equal to 20 e to the, did they give us, no, they want us to find k. So kt. So now they gave us this other condition to work with. So they're saying at t equals 2, so I'm going to plug in 2 right there. There's 5 grams of the element, so I'm going to plug in 5 into this. So it'll be 5 equals 20 e to the 2k power. And, oh, that's b. Yeah, they didn't even want us to solve for k. They just said which of the following equations can be used to find it. If this were a calculator question, I imagine they'd make you like do the whole natural log and decimal stuff. So that's about it. Perfect. I think that was one of my shorter videos. So yeah, I hate slope fields. And long story short, yes, I hate slope fields. I'm okay with the differential equations. But either way, hopefully that was helpful. Hopefully you guys are getting closer and closer to being ready for the AP exam. I now have to grade your FRQs. That's kind of where I'm at today. So yeah, I'll let you guys go. Take care. I love you guys, and yeah, good luck. Bye-bye.